Hi, so I'm Elise Jackson, and today I'm going to talk about my storage capacity flow duration curve, and as well as give some instruction on as to how to post both shapefiles and geoprocessing to the ArcGIS server. So for this project, our objective was to create a Tethys app capable of delineating a watershed, determining the reservoir volume for a specific dam height, and calculating a flow duration curve based on that location and also a curve number. So the data input that we need to run this app is a DEM, or a digital elevation model, a river shape file to snap the points to, a precipitation raster, flow direction and flow accumulation rasters, which are pre-processed, a dam location that is specified by the user, and a dam height and a curve number that are both inputs in the app itself. So here we are in ArcMap, which is where I created the main script and geoprocessing tool, as well as the shapefiles for the rivers that are later going to be put on the application itself. So I just wanted to show you a little bit about how this is set up in ArcMap and then how to publish this to the server. If you look here, this is where I created the scripting tool, which you have to set the different parameters, the sources, as well as the names and everything here. So on the parameters, you have to set both your input and your output parameters. So this pour point here is an input, and it has to live in a specific geodatabase. The height is also a string input, but then these are output parameters and live in the Scratch workspace. And we use this %Scratch workspace variable name just to tell the script to always put it in whatever the Scratch workspace that is specified by the script. So that's the same with the volume and results text files, as well as these two shape files that are generated by the script. So then you can run the script from in a local setting on your desktop, and this is that same tool that I was talking about before. So now this is the tool, the FDC calculator, and you can go in and you can snap a pour point to any one of these streamlines with a specific height and curve number, and this will run the tool and allow you to see the reservoir and the watershed that gets delineated as a result of it. So this is now the GeoServer page, or the ArcGIS server, which in our case is geoserver.byu.edu. And I'm inside my folder where I've published my services and my shape files, and you can see them here. So this is the base map that has the river shapefile as well as the DEM. And then I also have my process here, the FDC calculator, which is an asynchronous service. And I can see in here I've got my help URL, and I can see all of my different parameters as how they were set as inputs or outputs, what their spatial reference code is, basically all the pertinent information that you're going to need about your parameters. You can find it right here on this page. So this is the Tethys server. To access this app, you come to the storage capacity app and you just click on it to open it up. What opens up first is a bit of a help guide, just to help people understand how to zoom to location, points of interest, specify the dam height and the curve number, calculate the storage capacity, and then reviewing results. So you can just close that, and we see the shape file that we talked about earlier we saw in the ArcGIS. And now we can click here to draw the point, and we can zoom in anywhere we want on the map, and this map can pan around and zoom, and you can zoom into your point where you're interested in putting a dam. And we can just select a point here, put in a dam height and a curve number, and these values are there as just default values, but they can be changed. So for example, I can make this a 50 meter dam. And then you just submit your job, and it says request submitted, and then it will execute. And then this process takes quite a while to run. So while that's working, we're going to click here, which will open up the GitHub repository for this app. So here we have the README with the software details, helps people understand how to clone this repository so that they could work on it. A couple help pictures to see how it's supposed to look, and then some overall flowcharts of how the code works, as well as how the geoprocessing service works. So basically, in this app, you have a couple different inputs from the user. So this define point, where you just click, and then the dam height and the curve number All of these then go to the geoprocessing service that we created in ArcMap, which then runs the analysis, and then we get our storage capacity data, which turns into our storage capacity results, which is the watershed and the reservoir, and then the FDC data, which turns into the flow duration curve, which pops up on the results page. So this is still within that GitHub repository, and you can see my file structure, which is built by the Tethys scaffold, and under the public folder I have my JavaScript folder, an images folder, CSS, and my ArcGIS. So this is where my actual script for my tool lives, and you can see how the Python is set up so that we can run that geoprocessing service. So you have to specify your local variables. You have to specify a lot of these different environments, like the coordinate system, set your workspace as a relative determining where your tool lives. Same with your Scratch workspace, and then you have to let it overwrite itself. Then you have to specify what all these parameters are and tell them what variable in the Python they're going to be. Then as you go through the rest of this code, it just goes through and figures out what the average precipitation is going to be across your watershed, your average slope, assigns the curve number, and then defines the flow duration curve based on those parameters as well as the square kilometer area of your watershed. So then these all go into these equations based on what the percent flow is going to be, and that outputs a list of percentage of flows depending on each of these percents. So then these output as a text file that then gets accessed by the JavaScript and then posts to the controller so that the results page can pop up in the app itself. So here we are in the main JavaScript file that has all the scripting of setting up that map document and allowing everything else to run. So here you can see where I'm calling that stream file. So I'm creating a feature layer that's calling into that geo server and runs and grabs that shape file. And then here I do the same thing, but this time I'm giving it a geoprocessing task and telling it go and find the FDC calculator geoprocessing server. Then the rest of this is just JavaScript to create the pointer and allow the map to pan and zoom and everything else. And then when you click on the submit button, it runs this process right here where it goes and gets the result data based on the job info and the job ID, and then pulls the watershed shapefile, the reservoir shapefile, the volume text file, and then also accesses that flow list and posts that to the controller so that the Python script can then define the flow duration curve and the table as necessary. So here's the app after it has run. You can see that right here where we clicked our point, it has delineated both the watershed and the reservoir that would result from that 50-meter dam, which is pretty small just because it's not that big of a dam or that big of a stream. So it also delineates the watershed, which is this dark blue line. And then we also see the total volume of that reservoir in cubic meters. And then what also happens when we click that is this screen will pop up, which is the flow duration curve results, which gives the amount of flow that we can expect a certain percentage of the time. So 99% of the time we can expect 10.82 cubic meters per second at that point, and 20% of the time, or about once a year, we can expect a flow of 86.11 CMS. And then we also generate this nice flow duration curve that we can see, and we can see those different values as well. So this tab automatically generates, but you have to make sure that the pop-ups are allowed on this page, otherwise this tab will not open. So back to the GitHub repository, and this is my controllers.py file. This is where that table and that plot get generated. So here we use a request.get to get that flow list data from the JavaScript post, and then we format it into a nice list and an array so that we can then zip those two lists, the percent list and the flow list, together and create both the table and the line view, which generates this really nice results, which then this can be printed or downloaded to a PDF or a PNG as needed. So in conclusion, the overall process of this app is we first had to create a model builder in ArcMap that could do the analysis that we wanted, and then publish that model to a Python script that can then be accessed or published as a service, which can then be accessed by the JavaScript call to run the geoprocessing as a client instead of trying to run it through the web server. And then finally posting those results to the Python controller so that we could create that flow duration curve and the table. So that's my app, which defines the storage capacity and the flow duration curve at any given point within the Dominican Republic. Thanks. Bye.